Hello everybody. This video is about an activity we're going to do called speeding up and slowing down. Normally this activity would be done one of two ways, either with fan carts or with fancy carts that roll up and down hills. Okay? But since we're not in class, we're going to be using a simulation called the Walking Man. Right? Actually, it's called the Moving Man here, but this video is going to show this guy kind of walking what we tell him to do here. Now, I'm going to go through kind of how to do the simulation and how to do the activity. So hopefully here at this point you might want to open up speeding up and slowing down activity. It is of course linked to the schedule for uniform acceleration. So you'll notice here the first thing it tells you to open this up. There's also a link of course to this, right, to this moving man simulation. As it says, be patient, it might take a little bit to load, okay? It is not really intended to be done on a phone, so normally I don't care where you do these. Pivots work well on phones. Well, they're small, but still, you can do them on phones. This one's not going to work well on a phone, so you probably need to be on a laptop, a desktop, a Chromebook, something like that in order to get this one work, okay? So I'm going to run through these instructions. There's quite a few of them, but really it's just how to get everything going. And it kind of goes right along with each page, all right, has a different thing for you to do. Right? It gives you some instructions and some things, and these are listed here too, so hopefully you kind of have this out as you're working on it. So the first thing I want to show you here, here's the simulation once you get it loaded. It looks like this. Right? Here's our little walking man. This button down here is nice, reset all. If you're doing something and you want to go on to the next part, right, and you don't want all the stuff that you've done before, you just hit reset all, you hit yes, and boom, you'll be back to something that looks like this. Okay? So, next thing it says is there's two tabs up at the top, Introduction, right, and Charts, graphs is what I would prefer they call them. Introduction is where you're going to look at the motion. Right? You're going to examine the motion. Charts are when you're going to see the position time, velocity time, and acceleration time graphs of this motion. So we always want to start on the Introduction tab so that you can just see the motion a few times. What motion, you ask? Well, the motion that we type in by putting in a position, velocity, and acceleration for that motion. Okay? Where do you get those? Well, we go down to each different activity, right? At the beginning here, it kind of gives you an idea of what you're doing. This guy's going to be speeding up while moving in the positive direction. It says to observe him walking, starting from rest and speeding up in the positive direction on the Introduction tab. Pause the walk when he reaches the 10-meter position, which is all the way over here at the end. Okay, and I'll show you how to do that. So notice you have to set the following parameters. And there's, like 6 different ones of these you're going to do. Each one has different parameters to set up, right, to get the guy to do a different thing. So, it says position 0, velocity 0 meters per second, acceleration positive 2 meters per second squared. And be sure, there's some positives and some negatives in this, some rights and lefts. So we want to make sure we get the right sign in there as well, okay? So it's already a 0, so I just have to type a 2 in here, okay? And now it's ready to go. Okay, the next step says to press the play button, watch him walk, pause his walk at the position mentioned. In this case, it said when he gets to 10 meters. So we would press it, see him go, wee-hee. And you can stop it when he gets to roughly 10. I kind of overran it a little bit, but you get the idea. Now, do you want to see that again? Well, you could go to reset all and redo everything, type in the 2 for the acceleration, but they do have this little playback thing down here. See down here at the bottom? If you click playback, okay, now you can watch that motion again. There he goes. Right? That's what we just recorded. And rewind button, and you can watch it again, right? So you can watch this as many times as you need to. Okay. Next step is once you kind of get a grasp of what's going on in the motion, that's really what's up here, right? What you just saw me do is this stuff. So now we're in the middle here. Sorry, that's this stuff is what you just saw me do up here. Now you're going to sketch predictions for your 3 graphs. Right? So down here, you notice there's predictions. Position time, velocity time, acceleration time. Where do you think, or what do you think the shape of these graphs is going to be? Where do you think they'll start? Will they be positive or negative if it's a velocity or acceleration graph? Right? Will they be parabolas, diagonal lines, straight lines? Right? What will they look like? So take some time and actually make predictions. It's okay if your predictions are wrong. Right? We're going to see what they actually are, and then you'll have a chance to go back and think about why. Why did they look the way they did? Okay? If we go back here, you're going to sketch your 3 predictions, and then you're going to come here and do the same thing again, but you're going to switch to the Charts tab, okay? And then this little button is important. For some reason, it scales the acceleration to have to be really huge before you can see it on the graph, before it doesn't look like 0. So there's a little button that I'm going to show you here, all right? A little positive magnifier button, looks like this, that you're going to click to make the acceleration range be as small as possible. You need to do that before every time you run this throughout the entire, all 6 different ones you're going to do, okay? Then you're going to enter the same position, velocity, and accelerations you used before. You're going to press play, and then this is where the magic happens. You're going to see him walking, but now you're also going to see the actual position, velocity, and acceleration graphs. If we were doing this in real time, we might use a motion detector or a wheel on the bottom of the cart, right? And we'd be able to see this motion happen in real time. So this is a simulation, right? It's showing you perfect graphs, but it does go along with the motion, so it's not really all that bad, okay? So I go to the Charts tab. There we go. See how the acceleration goes from -60 to +60 meters per second squared? Okay, that's huge amount of acceleration. So I'm going to come down to here, this one, okay? And I'm going to click on it. You see how it made it smaller range? And I'm going to keep clicking till it gets as small as possible because I'm never going to have that big of one. So this is as small as you can make it. It goes from -4.7 to +4.7. I don't know why they didn't make it even numbers. Okay, this takes it back up, right? This takes it back down. This is the only one you have to do. You can see everything else on these. I wish it was easier to change the time scale. You can with this button, but I don't want to get that complex. So we have 0 position, 0 velocity, acceleration of 2. Okay? Now watch what happens when you hit the play button. He goes and walks, and the graphs are graphed. When he gets to 10, we're going to stop it again. There we go, right? And you see the graphs. Hopefully these are not that surprising to you, because isn't this basically what you did in the lab? It is, right? So you would sketch these graphs back on your page. And of course, to watch it again, you could hit playback, right? And then you could play it again. And notice it doesn't redraw the graphs, it just kind of shows you where you are on the graphs. Right? Rewind would take you back to the beginning of it again. Reset all, same button here, would wipe it out. So if you do reset all, yes, it wipes it out, and then you could, type it in again as a 2 and play it. It's whatever you want to do here, right? And you want to stop it. Oh, see how I forgot to change the scaling here? So this doesn't, it looks like a 0, right? But that's only because the scaling's so small. So every time I reset it, I've got to change this acceleration scaling. See, now it looks normal again. Okay? So you'll see here, there's a spot to draw your actual graphs. Now, if your actual graphs match your predictions, great. You're starting to get a handle on how these graphs are going to work, right? Hopefully you get better at them as we go throughout this activity. That's the point, really. But if they don't, stop and think a bit. Right? Stop and think a bit about why they're different. Right? Why did your graph end up looking different? Why did it start differently than maybe you thought it was going to over here? If you can't come up with a reason, stop into the meeting, to our Mr. Jackson's Google Meet, and ask him, right? And he can help you. Notice there's some questions here for you to answer about the slope of this position time graph and the slope of the velocity time graph. The point of these questions is to help you think through, if my position time graph looks like this is why my velocity time graph should look like this, and then that's why my acceleration time graph should look like that. With me? So these questions are kind of going to ask you that, like we did on the last video that you watched, right? Then I want you to make a motion map. That's dots, right? Position dots, velocity arrows, and acceleration arrows. right? So make a motion map, and then there's a couple of little questions to answer about the velocity, the sign of the velocity and the acceleration. Because one of the things that we're going to do in this activity is we're going to figure out what does it mean to have a positive acceleration versus a negative acceleration. We know what it means to have a positive or negative velocity, right? Positive velocity means you're going to the right, negative velocity you're going to the left. But what does it mean to have a positive or negative acceleration? And it might not be what you think it should be, which is why we're doing the activity. Right, so going back up here, that's what it's talking about here, all right, to do. So basically everything I just told you that's here, right, except the individual little instructions of how to use the simulation, right, are here. But then everything else is basically to do this whole page. Please do the entire page, okay? Don't just do the graphs and then go on to the next one. That would be more fun. I know the walking man is the fun part, but, you know, do the whole process because it's a story, okay? Answer the related questions. So do these one at a time. So you'll notice here then there's a second one, different situation, different parameters. You'll get a different motion. Each time you're going to watch the motion, and then you're going to graph the motion. Make predictions and then make a graph. Sometimes you start at a different position. Sometimes things are positive, sometimes they're negative. Make sure you're including that. Right? After the first 4, there's a little summary page where you're hopefully going to find a pattern, and then 5 and 6 are kind of fun ones. By the way, tomorrow I'm going to go over, or actually after this activity, and you look at the post activity, going to go over 5 and 6 a little bit at least, and show the size or the shape of the graphs and the motion maps because they get a little complex. Right, so see what you can do here with the motion maps as well. And I'm going to get a key that you can check as well because not being in class at all, right, that might help. So I hope you're good with that, right, so that you can do this little simulation. Again, introduction page is where we start, right, and then after you've made your predictions of what you think the graphs are going to look like, then we look at the charts tab. Please don't just do this one, right? I want you to think a little bit here, right? There's a lot of thinking in physics. Take your time, right? You have plenty of time to do what's assigned for today. Take your time and do it well, right? Ask questions if you have them about why things aren't looking the way you thought they should look, or why they, you know, what should the motion map look like? Check the key, you know, compare. Let's do that kind of thing. Okay? So go ahead now and look on today's day on the schedule, right? And start to check out all the things that you can download. Hopefully you've watched the video already. Here's the activity sheet, right? Here's the simulation, and it says, right, doesn't work well on a phone. Follow the instructions, do a whole page before you go on. When you're done with all of those, you will then be able to watch this video, which will be there by the time you need it, right? Post-activity. Like I said, this is kind of going over the summary page and 5 and 6 a little bit, the more complex ones. Enjoy!